For those that are joining us for the first time, this is the Apologetics Academy. The website is apologetics-academy.org. I'm Jonathan McClatchy, and I host this weekly webinar where we bring on different scholars from across the theological and philosophical spectrum to present to us on topics that are of interest to Christians, particularly those topics which pertain to the question of whether or not the gospel is true. And we also cross-examine and evaluate other worldviews such as Islam, Mormonism, atheism, and so on. There's a number of ways that you can participate in this live interactive webinar. You can simply sit back, or relax, and enjoy the program if you want. You can also participate in the chat window. If you're doing so, please direct your chat to everyone rather than just panelists. That would be great. You can also submit questions anonymously if you wish in textual form by hitting the Q&A button, which is at the top of your screen. And at the appropriate time when we get to the Q&A, I will read your question to our guest speaker and he will do his best to respond. You can also click the raise hand button at the top of your screen, and I will, during the Q&A, promote you to be a co-panelist with the speaker, and you'll have opportunity to engage and dialogue and discuss. You're particularly welcome to do so if you're a skeptic and you want to ask skeptical questions, and that's brilliant as well. And just to give you an idea of what's coming up in the coming few weeks, on July 1st, we have with us Dr. Andrew Fabich, who is a microbiologist, and he is going to be presenting a critique of a popular argument for common ancestry, namely the nested hierarchical distribution of endogenous retroviruses in primate genomes. And then on July 8th, we're actually going to not be on because I have a speaking engagement down in Leeds. So I'm not going to be hosting a webinar that week, but on July 15th, we'll be back and we'll be with Dr. Michael Brown, who is a well-known biblical scholar of askdrbrown.org. And he is going to be giving us a presentation on winsomely and graciously reaching the LGBT community with the transforming message of the gospel. He is the author of A Queer Thing Happened to America, and he's done a lot of discussions and debates on the topic of sexuality. Then the following week, on July, or actually the following week, I've still got to schedule one, but on July 29th, we're going to be having Hilary Ferrer, who's going to be giving us a presentation on diagnosing doubt, how to stop wasting time answering the wrong questions. So coming back to this evening then, we are very honored to have with us physicist Dr. Brian Miller from Discovery Institute, and he is going to be speaking to us this evening about thermodynamics and the origins of life. Dr. Miller comes from an intelligent design perspective. Dr. Miller, for those that haven't perhaps come across you before, do you want to maybe just briefly introduce who you are and tell us a bit about some of your background and then just launch into the topic? That would be awesome.
Sure. Yeah, I have a PhD from Duke University in non-equilibrium physics. Technically, I'm from the Center of Complex Systems and Non-Equilibrium Dynamics. So I finished my PhD, and then I've done consulting. I've worked in the ministry world, and then more recently, I've come on board Discovery Institute. And some books I've helped to write that are out in the public are God's Not Dead and Man, Myth, Messiah. So I've had my hand in different circles, but the issue of the thermodynamics of the origin of life is a topic I'm particularly interested in because it somewhat relates to my field of study. Because what I've noticed over the years is a lot of people have talked about things like self-organization, autocatalytic pathways, those sorts of ideas, and they appeal to concepts from my field, but often they do so in ways that aren't necessarily completely accurate. So I've spent the last year really focusing on this topic, and I've just recently done 3 articles for Evolution News website, Connected Discovery, and I have one more article coming out soon. So if you want to know the details, they're in those articles. But let's sort of begin and talk about what have people done to critique the origin of life. And one of the common critiques you hear is simply that life is too improbable. And if you want to think about what do origin of life scenarios look like, the idea is you had some primordial pond back at the early stages of the Earth, kind of like in this picture, or perhaps you've had some water near a thermal vent at the bottom of the ocean. And the idea is that you've had some basic chemicals in this environment, and then it was injected with energy, either a radiation from the sun, or heat from a thermal vent, or high energy chemicals, or something along those lines. And what happened was you get the building blocks of life, and those building blocks of life eventually come together. They form more complex chains. Eventually, you have it somehow surrounded in some sort of membrane. A metabolism develops, and eventually you have a functional cell. There's a lot of scenarios for exactly how that happened, and certain things are in different order. But the critique is always that it's too improbable. And the idea is that if you have all these basic building blocks of life, you have all the amino acids, the nucleotides, lipids, the chances, if all of these atoms arrange each other randomly, is incredibly small for it to actually form a functional cell. And the basic idea is that until you have a fully functional cell with a functional metabolism, even if you were to get close to the target of life, thermodynamically, it would break down and fall back into simple chemicals. So the idea is you have to basically go to simple chemicals up to something that functions properly as a cell, but that's just too improbable. In fact, if you look at the sorts of numbers that are associated with, you can think of it almost like you're rolling die. It'd be like trying to roll a certain number of sixes in a row. And the probabilities often mentioned are like 1 in 10 to the 40,000. And that's a number that comes from people like Fred Hoyle. He used the analogy that the origin of life is like a tornado going through a junkyard and throwing all this junk up in the air and ending up with a 747 Boeing airplane that's filled with gas and ready to fly. So the idea is just simply too improbable, therefore it couldn't have happened naturally. Well, that argument sounds compelling, but it's really not complete. And the problem is you have at times very improbable things that do happen. Like if you imagine that you have, let's say, a lot of atoms, and those atoms have a certain spin, the likelihood of all these atoms randomly coming together and forming a straight line with all the spins in one direction is really, it's impossible, it's too improbable. But if you had, let's say, a magnetic field, then what happens is the force caused by that magnetic field would cause all the atoms to line up in this highly improbable state. Another example is that if you look at ice is a much lower probability configuration of atoms than water if it was just purely a random, if you essentially had a lot of fair dice. But clearly ice can form. It has very low probability, yet it still forms. Now, another connection to the idea of probability is the idea of entropy, because entropy, if you're dealing with, let's say, a microcanonical state, entropy is defined as proportional to the natural log of the number of configurations associated with a common state. So what happens then is the number of configurations obviously relates to the probability. If there's more ways for something to happen, it's more probable. If there's more ways for it to happen, it has higher entropy. So probability and entropy are directly related. Lower probability states have lower entropy. Higher probability states have higher entropy. So what happens is things do tend to go from states of high entropy to low entropy, meaning they tend to become states of low probability. Again, I use the example of water freezing to form ice. So what happens is a lot of people in the origin of life might argue that you may have some physical conditions that biased nature towards life. So although life seems to be a very low probability state, there may be physical processes that bias nature towards that direction. Well, that sounds reasonable, but it actually doesn't work. And to understand why it doesn't work is you can ask the question, how are various states biased? Like again, if I use the analogy of rolling die, when will the die be biased for you and against you, or for towards a certain state or against a certain state? And what happens is that bias is related to the energy of the state. So that gets to another driving tendency. The first driving tendency, as I talked about, was entropy, but the second driving tendency is that nature wants to go from states of high energy to states of low energy. So low energy states are biased more greatly than high energy states. So again, what happens, you have these two driving tendencies. One is nature wants to go from states of low entropy to high entropy, which simply means that nature wants to do things that are more probable, and nature wants to go from states of high energy to low energy. And if you work in chemistry, often you may have heard of the Gibbs free energy equation. Well, what happens, you can combine the idea of entropy and energy in what's called the free energy. And that's what's done if you've got constant temperature and constant pressure. So what happens is the change in Gibbs free energy is equal to the change in what's called the enthalpy. And the enthalpy is simply the energy, except if you have constant pressure, you're compensating for the fact that you may have an expansion or contraction of the volume. So again, the free energy is equal to the change of free energy is equal to the change of enthalpy minus the temperature times the change of energy of entropy. So what happens at low temperature, nature is biased more strongly towards low energy states, and at high temperature, it's biased more towards high entropy states. And the challenge, though, for the origin of life is that life is both high energy and it's high order or low entropy. So in other words, life requires nature to go against its natural tendencies in terms of energy and against its natural tendencies in terms of entropy. And nothing in the universe ever does that. So you'll never find a physical system that spontaneously goes to both higher entropy or lower entropy and higher energy at the same time. So let's talk again, let's again use the example of water freezing. What happens when water freezes is it does go to a state of lower entropy, but what happens is it releases energy. So the energy it releases goes into the environment and it increases the entropy of the environment more than the entropy is lowered in its local state. So the overall change of entropy in the universe is still positive. It's getting higher. But in life, what has to happen is because you're going to a state of low free energy to high free energy, the entropy of the universe is actually decreasing, which is physically impossible. In fact, what's happened is a physicist named Dr. Harold Morowitz wrote a book called The Free Energy of Life, or Energy Flow in Biology. And here's actually the book, Energy Flow in Biology. It's a very nice book. And he calculated, based on modified probabilities, taking into account the energy, what's the likelihood of life forming by some series of thermal fluctuations. And the probability drops from 1 in 10 to the 40,000 to 1 in 10 to the 100 million, actually less than that. So what happens is it's kind of like you're trying to roll a 6 50,000 times in a row. But the problem is that the 6 is very strongly biased against it. So it's a loaded die, where a 6 only comes up once in, let's say, 1 billion times. That's the problem you're dealing with the origin of life. It's extremely problematic. Well, many people realize this. So what they argue is for a particular loophole, and that's the idea that you're not dealing with a system that's near equilibrium. And that's what the field is of like classical thermodynamics. And that simply means you've got systems where you don't have huge temperature differences or concentration differences. Everything is fairly stable and happens relatively slow compared to relaxation times. But the idea is if you have what's called a non-equilibrium system, like you're strongly driving the system with energy or high energy chemicals, and you're keeping the system far from equilibrium. In those systems, the classical thermodynamic analyses, which I gave you, tend to break down. It's not so easy to define things like entropy. So the hope is that in those systems is where life formed. Now, another feature of these systems is that you tend to have spontaneous order creation or self-organization. Now, a classic example is that if you have a container of water and you heat it from below and you cool it from above, what happened, just a second, I think my screen just stopped sharing. Well, I'm just going to start talking and try to get this back operational. The idea basically is that when you're dealing with a non-equilibrium system, you can get spontaneous order formation. So in other words, what can happen is you have a tornado cloud. And what happens in a tornado is essentially you have a system that's a non-equilibrium system, so it's far from equilibrium. and you're seeing heat and energy come in and heat and energy come out. And through that flow of heat and energy, you get the spontaneous order formation of a funnel cloud. That's the basic idea of the non-equilibrium order formation. Now, what happens is you can have also what's called a chemical non-equilibrium system, which is like the BZ reaction. And the idea of the BZ reaction is you've got these coupled chemical reactions, and you have certain reactants being put into the system, you have excess fluid removed, and this flow of material through the system causes these wave patterns to form. Again, a form of self-organization taking place. Now, the question is, can that actually help with the origin of life? And the answer is it can't. And there's two reasons for that. One is the order formation in these non-equilibrium systems is very, very different from what you see in life. And that's at the macro level. And at the micro level, everything that happens in these non-equilibrium systems is doing the opposite of what you really need to happen for the origin of life. So in terms of what do these systems look like? One is you typically have dynamic patterns of like fluid creating patterns in motion. You typically have sort of this macroscopic order taking place. You also have processes that are spontaneous, meaning that there's natural laws driving them. So that's kind of what these non-equilibrium systems look like. Now, when you look at it, though, at the microscopic level, you start to end up with problems. Because what nature wants to do is nature wants to go from regions of high concentration to low concentration. So if you, let's say you drop a sugar crystal in your coffee, it will mix throughout the entire coffee, and it'll become more and more dilute. The challenge, though, is in origin of life. If you look at all the basic experiments, whatever produces the building blocks of life, like the famous Stanley Miller experiment, produces it in very small concentrations, and it's always mixed in with lots of contaminants. So for origin of life to work, you have to take this very dilute solution of these building blocks and make it much more concentrated and purified. Well, nature wants to do the exact opposite. Also, what happens in all realistic origin of life experiments is you'll get chemicals which are both left-handed and right-handed. So in other words, if you look at amino acids or sugars, they have both a left-handed version and a right-handed version, which are identical, but they're mirror images. And what happens is to get the origin of life to work, you have to have only one-handedness of particular chemicals. Like you have to have left-handed amino acids for modern life and right-handed sugars for life, or vice versa. But the challenge is, if you have a mixture where, let's say the mixture is 95% pure left-handed amino acids, as the amino acids interact with each other, they balance out so that they eventually become half left and half right. So again, what nature wants to do is the opposite of what's necessary for origin of life. Also, all spontaneous chemical reactions go from high free energy to low free energy, but life wants to go from low free energy to high free energy. So again, life is wanting to do the opposite, or what life needs to do is the opposite essentially of what is essentially the opposite of what's required. Okay, now that's the macro level, but now let's talk about the micro level. If you look at the micro level, or if you look at, let's say, how the micro goes to the macro level, we can start to really understand why these self-organizational patterns are not helpful for the origin of life. Because the self-organizational patterns are dynamic. You've got fluid in motion, you've got chemical reactions that are creating patterns in motion. But the order in life is structural order. It's rigid and fixed. Like a lot of it, there's things like amino acids in specific sequences. There are atoms forming complex molecular machinery like ATP synthase. You've got a cell membrane where many of the molecules are fairly stable in place. So the order is very different. Also, when you look at these non-equilibrium systems, they're constantly generating entropy. Even at the microscopic level, what's happening is you've got these differences in temperature, these gradients in concentration, you've got inhomogeneities, and these gradients, these differences, produce what are called thermodynamic flows. Like you'll have heat flowing, you've got diffusion, And whenever you have that, you actually generate entropy at the microscopic level. So while origin of life needs lower entropy at the microscopic level, these non-equilibrium systems create more entropy at the microscopic level. Also, what happens is spontaneous systems, again, go from low free energy, high free energy to low free energy. But when you look at life, both in the origin of life and in many of the specific reactions that have to take place, you're going from low free energy to high free energy. Again, that's the opposite direction of what normally happens. And in these, again, these non-equilibrium systems, you have law-driven patterns, things like Navier-Stokes equations, reaction rate equations. But in life, the order is specified complex, meaning you've got arrangements of atoms that are form configurations which are very different from what nature wants to do, but those are improbable configurations that achieve functional goals. In other words, they represent patterns which are meaningful. So again, if you look at the comparison of the two orders, they're absolutely different. So what happens is natural processes will not create the order you need in the cell. What you need is machinery and information to create cellular order. And to explain that, let me use an analogy. Imagine that you go home after a long vacation and you find that your spouse or your children have completely messed up the house, or your roommates. And you want to put your house back in order. So that means you have to clean the dishes, you have to vacuum the carpet, you have to put up the clothes, and so forth. Well, you might think maybe energy is all it takes to create the order that I need. So you put gasoline on your couch, you set on fire, and you hope the energy coming from your house, from your fire, will create the order you want in your house. Well, obviously that's not going to work. The order, you're actually going to create more disorder from your burning furniture. Instead, you realize what you need is like a robot. So you buy a solar-powered robot, and the solar panels on the robot convert the energy from the sun to useful work in the robot. But that still is not enough, because if the robot starts randomly throwing around furniture, that doesn't help. So you also need to program the robot with the right information on how to order the house. And the exact same thing is true in cells. The reason cells can maintain themselves in a state far from equilibrium is because they've got lots of advanced machinery. Like in modern cells, you've got ATP synthase, you have chloroplasts and eukaryotes, you have these different machines which will process either sunlight or chemicals to produce energy. Now, the ancient life, the first life, whatever you imagine it to be, may have used different machinery, but it still needed some type of machinery to help process energy. But that's not enough. You also have to have enzymes and proteins. In other words, what happens is you've got to have sequences of amino acids which form highly specific chains that have very specific orders, so the chains will fold in the proper proteins. So for instance, these proteins can be enzymes, and the enzymes have a very specific three-dimensional shape so that they can drive the right reactions at the right time in the right amount. And also you have to have proteins that would create the structures in your cells. So what's really important about this is actually how you overcome the free energy barrier in cells. Because what happens is a lot of the reactions in cells go uphill. They go to higher free energy. However, what these enzymes do is they couple reactions that go downhill with reactions that go uphill. So a classic example is you've got ATP. So ATP will turn into ADP in phosphates that will actually release energy. Well, the enzymes couple that reaction to, let's say, amino acids forming chains. So the net free energy change is actually negative, so that allows you to overcome the barrier. But that only works because of the very specific three-dimensional shape of these enzymes, which is because of their very specific orientation, their very specific sequences. So again, what you have in these proteins is amino acids in very specific orders, almost like letters in a sentence. And the problem is that information can't be created by any natural process. Now, many people have argued that perhaps you can get information from a reduction of entropy, but that won't work. And here's why. And let me use a simple analogy. Let's imagine that you have a bowl of alphabet soup. and you leave to go to the restroom, and you come back and you notice that there's this message in your soup. You will have success in business. Well, you might ask yourself, could this ordering of letters be produced by the chemistry of the pasta? So perhaps if you just understood more organic chemistry, you could explain the sequence. Or perhaps you try to explain it through the boiling of the water. So perhaps the physics of boiling water creates self-organizational patterns, which will create this message. Now, clearly that's not going to work. The only way to arrange letters in a specific sequence to create a message is with an outside intelligence or ordering it for a specific goal. And the exact same thing is true in cells. There is no physical way to get the amino acids in the right order to create the right enzymes to drive the right reactions. It has to be a product of the mind. Now, the situation is actually even more problematic, because if you look at the early life, what happens is early cells will break down. So proteins break down, the machinery breaks down, and proteins don't self-replicate. So you have to have the machinery in place that will allow new proteins to be created to replace the ones that are being broken or breaking down. So the only way that can happen is with the complex machinery you have in life. Perhaps it's different, but it has to be some complex machinery that will store information, will extract that information, and then use it to create new building blocks. Now, where is that information stored? Well, clearly it's stored in DNA. So what happens is you have every amino acid in your protein is encoded by a set of 3 nucleotides. Like valine may be coded by GUG. And you've got 4 nucleotides in DNA, so it's a 4-letter alphabet. So what happens is this chain of amino acids is translated into the language of DNA, or perhaps RNA on the early Earth. Now, there's a problem, though. There's no chemical connection between the amino acids and these what are called nucleotides. A nucleotide is simply the 3 nucleotides, or a codon is simply the 3 nucleotides that form that piece of translation. So every amino acid relates to 1 codon, but there's no chemical connection. If you were to take a vat of amino acids and a vat of codons, you would not see the amino acids more strongly attached to their associated codons than to other codons. And because there's no chemical connection, there can really be no plausible physical explanation of how this encoding took place, meaning the information had to be encoded separately. Now, here's again just a picture of the modern genetic code. And again, just to depict it, is you have to have protein sequences which are both encoded and decoded from the different languages, but there's no physical connection between the two. Now, we do know how decoding takes place. But the way decoding takes place is you have your sequences of nucleotides, and they run through a machine called a ribosome, and then you've got these special tRNAs, which will link the right amino acid to the right codon. Now, the way that happens is every tRNA is associated with a particular amino acid. And the way they get stuck together is through these special enzymes called aminoacyl tRNA synthetases. And also, this particular enzyme also captures an ATP, and that's how you get the energy to combine the amino acids together, because they wouldn't normally combine without extra energy. Now, the key, though, is that this connection between amino acids and their codons is mediated through these special enzymes. So there's 20 separate enzymes related to every amino acid. Now, the way that works is that they have a very specific 3-dimensional shape, which is again determined by the information in the sequence of amino acids. And that, incidentally, is the information which is a part of the information encoded in DNA. So here's the challenge. We have no idea how encoding took place, but again, the decoding takes place through this machinery, but this machinery all depends upon proteins. So ribosomes contain proteins, tRNAs are partially structured by proteins, and then aminoacyls are proteins. And again, as I mentioned, the aminoacyls are what encode the actual key for the decoding. Now, here's the problem. The encoding and the decoding had to use the same code, or else it wouldn't work. Like Morse code, you've got to encode it with the right key that you decode it with. But there's no possible physical connection between the encoding and the decoding, because the decoding is from those amino acyls, which are arbitrary. They could be anything. So what that means, practically speaking, is that the information, which had to be both in proteins and DNA, and the code had to pre-exist the actual cell, because it has to essentially be all there in place. Encoding is usually without decoding, and you have to have information in both the proteins and the DNA. And the only place that information can exist outside of physical reality is a mind. So that points to the idea that a mind produced the code and the information, which eventually was instantiated in the cell. Now, the question, though, is appealing to a mind or intelligence scientific. Is that acceptable? Well, let me ask you a question. If you were, let's say, a geologist and you come across Mount Rushmore, you have two options. One is you could say that you're going to try to explain that through natural processes, either through wind or erosion, or you could say it's a product of intelligence. Now, clearly it looks designed because you have pictures of faces of presidents. But if for whatever reason you refuse to accept that possibility, you could keep looking for how wind and erosion can produce those patterns. But clearly that's something that's never going to happen. Well, what if that wasn't on Earth, but what if you were the first astronaut that went to Pluto, and when you get out of your spaceship, you see this picture on Pluto, essentially faces of aliens. Again, even though you have no knowledge of there being aliens on Pluto, you would immediately recognize that this is designed. Well, what if you started to fly back in your spaceship back to Earth, and you have this signal that suddenly is emitted from Pluto, and this signal actually creates the schematics of a spaceship. Well, again, you would not try to explain that through solar flares or through some sort of solar radiation, but you would know that was designed because it shows information and intention. Now, if you look at the bacteria, essentially the information in the bacteria is like the schematic of a spaceship. You see the system, which is physically impossible to come about, which contains lots of information for a purposeful goal, which again points to design. So thank you very much.
Thank you, Dr. Miller. This is the interactive portion of the program. If you would like to interact with what Dr. Miller has said, then you can do so by typing in a question using the Q&A button at the top of your screen. You can also submit questions on Facebook if you wish, and you can also click raise hand, and I'll promote you to be a co-panelist with Dr. Miller. We had a question submitted. I don't know whether you want to take this question because it's more theological, but you can tell me. Jonathan Hanna submitted a question. Dr. Miller, I'm not a scientist, for I am a total layman in that area, but I thank you for the presentation today. My issue has to do with the biblical text itself. It seems that if biblical scholar John Walton is right, then the origins debate is gone. Hugh Ross and others disagree with Walton's theory of Adam. It seems that Walton somewhat follows Galileo, who said the Bible shows the way to go to heaven, not the way the heavens go. That the author of Genesis had no idea about deep science and the like. Would you agree with John Walton's theory that Adam and Eve also, would you generally agree with Galileo? Do you want to take that, or is that?
Yeah, that'd be fine. So the question really is the idea of how do you interpret biblical text? Like, do you interpret Genesis literally, or do you accept it's more of a narrative that models ancient Near Eastern creation stories? Mm-hmm. Well, that's a really interesting question. And I would argue that you see, and again, there's really two perspectives of what the world is like, or there's multiple perspectives, but two perspectives. One is the idea that God created the world, at least from a Christian framework, but then he allowed science to move forward unaided. So it's almost like a clock that was started and then it just kept on going. Another view is that the metaphor is not that of a clock, but a flute, a musical instrument, that God created the laws of physics, which were necessary for life, but they were not sufficient. That God designed our world such that he would continuously interact with it. That in the same way a musician interacts with a flute to produce music, that God was infusing the world with information continuously. Perhaps that looked very sudden and dramatic. Perhaps it was over longer periods of time. But the issue is, did God create a clock or a musical instrument? And I would argue that regardless of how you interpret Genesis, the science points to the idea that the world is more like a flute. God created the laws of physics to maintain the universe, but he was involved in the world, injecting information into the world at the origin of life, at the Cambrian explosion, at the production of humans. So I would say that's where the science is. Now, given that science, we can go back to the text and ask the questions, how do we understand the text in relation to the science? And I would say the text fits very nicely. The spirit of Genesis is that God created the universe out of nothing, which is what we see. He created life. He's the originator of life, and that's completely consistent with the design we see. Now, someone like Walton might go more for a theistic evolution perspective, which is the idea that humans came about by a slow, gradual process, and eventually God intervened in some way. But I would argue, based on the science, which is not something I can get into, that if you look at the species on the Earth, you see more evidence of infusions of information, that there is an unbridgeable gap between our primates. Even if you believe in common ancestry, there's an unbridgeable gap between our primate ancestors and us that could only be filled with information to help produce all the complex structures in the brain in such a short period of time. And that's parallel to what you see with the origin of life.
Awesome. We had a hand raised from Salvador Cordova. Is that Sal?
Yes, that's me. Can you hear me okay?
We can hear you just fine.
Dr. Miller, it's a real honor to speak with you. Say hi to all my friends at the Discovery Institute.
Sure.
I'm developing college-level creation science and intelligent design courses. But I actually just wanted to point out, I actually de-emphasize thermodynamic arguments. I think the way you presented everything today is very powerful. That if I made the same presentation, I probably would remove the thermodynamic arguments. One of the reasons is that the example that I use is if you take a live cow at, say, room temperature, which would be about 25 degrees Celsius, and then you bring them down to 0 degrees, close to 0 degrees Kelvin. Your average physics, chemistry, mechanical engineering student, if you're asked to give an estimate of the change in entropy, the dead frozen cow actually has lower entropy than the live cow.
Right.
And that's kind of the thing that I deal with. So that's one reason I just totally steer away from that. The other thing is there is some debate whether entropy actually is a measure of order or disorder. In a lot of chemistry textbooks, it will say entropy is a measure of disorder, but some chemists like Frank Lambert have argued that both Boltzmann and Gibbs probably made some passing remarks that they probably wish they would have back. So I just wanted to point that out, but thank you very much for your work.
Thank you. If you could email me specifically what you meant by that last comment, I'd be appreciative. And my email is bmiller, B-M-I-L-L-E-R, @discovery.org. Let me deal with the frozen cow example. One, because it's such a pleasant image, but two, because it's a common topic that comes up. And people argue, again, that if you lower the entropy of a system, that can somehow equate to a raising of the information of the system. That is not true. What people make that mistake because they equate information to Shannon information, which uses the same mathematics as entropy. So it works in one direction. Like if you've ever read the Mystery of Life's Origins by Thaxton.
Oh, yes, absolutely.
Yeah, he talks about how if you look at the amount of ordering in a protein sequence, that increase of specificity relates to a decrease of entropy, which means you need a certain amount of energy, of work, to drive that increase of information. That works. But it doesn't work in the reverse direction, because Shannon information and functional information are different. And the analogy I use is if you have, again, a bowl of soup with letters in the soup, and you freeze the soup, clearly you're dropping in entropy, But that drop in entropy cannot be translated into forming a message in the soup. You won't see the Declaration of Independence. So again, beyond super technical details of how you define entropy, I think in a practical, everyday chemical situation, the way I defined it, people wouldn't dispute with my basic points. What origin of life people try to do, in fact, my last article on Evolution News goes into this, is they try to argue that you have natural chemical cycles. Like at the bottom of the ocean, you might have like some sort of volcanic pool that heats the water and then cools it, so you get a cycle taking place. And they hope that perhaps you have like an ATP, or I'm sorry, an ADP and a phosphorus, or a phosphate. And what happens, you may have an enzyme. So as the system cools, this enzyme can combine the ADP with the phosphate and form ATP. But then what happens is you've got this enzyme that's stuck to it, but when this goes back into the hot water, the heat causes the enzyme to release. So you essentially have an engine. Heat goes into the enzyme releasing it. It's removed when it folds, and that energy is what gives the energy necessary to combine ADP to phosphate. So imagine these natural thermodynamic cycles in the early Earth to overcome the free energy barrier. The problem is, when you look at the details, these cycles are fantastically inefficient. Like in a cell, a bacteria creates billions of ATP in an hour, while these makeshift systems could only produce a handful in like a month. So this issue is very real. Some people are trying to solve it, but they have to solve it through fantastically improbable scenarios.
If I could just check, you said B. Miller at discovery.org?
That's correct.
Yes, I would be very happy to dialogue with you. I should point out, I'm kind of in the minority in the ID community. There have been a few ID people, including Walter Bradley, the co-author of Mystery of Life Origins, who he actually said in a rare article he didn't think the second law formally precludes the origin of life. He does use thermodynamic arguments throughout that. The other author would be Percival Gange. Right. So anyway, I just wanted to point that out. I will be happy to email you those things and some of my other thoughts, but thank you very much for your work. It's an honor to talk to you.
Oh, no problem. And you're right. It doesn't formally disprove it, but what it does say is that you have this enormously difficult problem, and nothing in the universe does what needs to happen with life. And the way you formally solve the problem is the way cells solve it. You have to solve it by a cycle which will process energy, and then you have to direct that energy to the order that you want. So the way cells solve it is they use machinery and information, and I would argue that there is no way around that problem without those two conditions. So that's my main point.
Yes, I usually call it the chicken and the egg paradox. I happen to have studied at Morowitz's school and under his Origin of Life colleague, James Trefel. I mean, they actually helped persuade me of the IT position of all things. So thank you very much.
Yeah, let's stay in dialogue. What is your specialty, by the way? What have you been trained in?
I studied applied physics at Johns Hopkins University. Okay. But right now I'm a biomolecular research assistant for John Sanford. I don't know if you're aware.
Oh, of course. Yeah, please
yes.
Email me and we'll talk more.
Yes, he and I and some others are actually developing courses at the college level to teach intelligent design and creation science.
Great.
And, so we're finally trying to build some bridges with the Discovery Institute. We've been sort of disconnected, but we're trying to reestablish.
I am deeply interested in this whole idea of genetic entropy, and I've been wanting to contact him, so this is really good.
Okay, we'll be in touch. And my email, you'll recognize it. It's a Hotmail account, but you'll see my initials and everything. So I look forward to talking to you. God bless you, sir.
Thank you.
Thank you, Sal. Okay. Let's go to our next submitted question. Alistair says, misstart of talk, so sorry if covered by speaker already. Do you believe in God? If not, do you see that life originated with no intelligence behind it, or feel many things are difficult to explain without intelligence or God?
Well, I'm a Christian, so I'm a Christian that's of a little Orthodox Christian, so I subscribe to the historic Christian faith. So I definitely believe that God was involved in the creation. In fact, just a little bit of my story is I was raised in the church, but I lost my faith after reading a book, Richard Dawkins' book, The Blind Watchmaker, and also took a class on the Bible that sort of argued that it was mythology. So I became pretty convinced that Christianity and all religion was a psychological crutch. And what helped to bring me back to faith was, one, the evidence for design in the universe, the fact that the laws of physics were so carefully designed to allow for life. Two was the book I read by Michael Denton called Evolution, Theory, and Crisis. And then eventually books like Michael Behe's Black Box and Darwin's Black Box and other apologetics helped me to get back to faith. So I would say that the scientific evidence for design and direct intervention, I would use those words very softly because I don't know exactly what it looked like, it helped to bring me back to Christianity.
Cool. Jonathan Hanna asks, some skeptics bring up that inferring design is an issue of special pleading. How do we respond to this objection?
Well, I would ask the question, I'd use the analogy again of if you go to Pluto and you're the first person on Pluto and you see an image of an alien face on the mountain, or to use the example of the movie Contact. If you happen to see the movie Contact with Jodie Foster, they receive this signal from space. The signal begins with a lot of prime numbers. It also contains the blueprints of a spaceship. If you argue that that signal was designed because it contains information, is that special pleading? Is that the alien of the gaps theory? Or is that based on the reality that information that shows intentionality only comes from design? It's a telltale sign. So I would argue that it's an inference to the best explanation. It's not a special pleading.
Oops. Cool. If anyone else wants to interact with Dr. Miller, then just simply click the raise hand button and I'll be happy to promote you to a panelist, or you can also submit questions using the Q&A button, typing it in textual form. We often hear, Dr. Miller, about when we talk to atheists and one brings up the laws of thermodynamics, it's kind of, they immediately turn off at that and they say, well, you know, this is a straw man argument that naive creationists make, because everyone knows that, you know, the Earth is an open system and the second law of thermodynamics only applies to closed systems, whereas we've got this constant influx of energy from the sun onto our planet. But what I think you presented today is that actually there's a far more sophisticated way of framing the second law of thermodynamics as an argument against the materialist understanding of life's origins, which kind of militates against that. How do you typically broach this subject with atheists when you talk to them?
Well, what I do is I present the counter argument like I did today. So I say, here's what's been presented in the past, here's why it's not complete, and here's what's missing. Because the problem is, and again, I have to emphasize, my lab studied self-organizing systems. I've read graduate books on non-equilibrium thermodynamics. And what happens is most of the people, nearly all the people that criticize the arguments haven't studied the exact details. It's more of a meme that's been passed around our culture. Thermodynamics doesn't apply. It's just sort of an urban legend. But when you actually look at the details of what happens in these self-organizing non-equilibrium systems, the key is that they generate entropy at the microscopic level. You get more entropy, not less. So the more you look at the details, the more compelling the arguments become. But you have to know, you have to be a specialist to know where these arguments are. See, that's the challenge, is to translate them to the public. That's why I think the analogy of setting your furniture on fire to organize your house is so powerful, because it sounds like a silly example, but that's exactly what people are saying about life. A cell is as organized as the best organized house, and energy from the sun or from a thermal heat source will have as disruptive of an effect on a cell as setting your furniture on fire. So that's the challenge.
Yeah. So putting a bull in a china shop is an input of energy into the system, but it's not going to organize your china shop.
Exactly. And the key, and again, the key is there has to be a mechanism to process the energy. You have to have an engine which can extract the energy and then direct it with information to create the order you want. That's the key. Mm-hmm. Because even if the energy is not a problem, even if you can have all the energy in the world you want and do whatever you want to do with it, the problem is the ordered systems that represent life are fantastically few compared to all other ways you can order matter. That's the challenge.
Mm-hmm. Someone with the alias Big D in the Q&A asks, could you suggest a good book on this topic? I had dismissed this argument before, but you have given me a reason to rethink this.
Unfortunately, there really isn't. I've never seen this argument before. So not in the same form. People have talked about it more superficially, but I haven't seen it out there. I've just done a series of 4 articles on the Evolution News website, the articles for our online magazine. So that's a great start. I think, again, the classic Unlocking or The Mystery of Life's Origins still is some of the most thoughtful arguments about it. And if whoever asks the question wants to email me, I can think more about who may have done other types of work on the topic.
I think, Granville Sewell has done some work on this topic, and it's kind of along the similar lines to what what would you say is the difference between what you're proposing and what he's doing?
Well, I have read one of his articles, and we are saying almost exactly the same thing. I do it a little bit more formally, though.
Okay. So you might want to go check out his articles. There's one published, I think, in Applied Mathematical Letters, if I'm not mistaken. And if you Google his name in thermodynamics, you'll find his stuff that he's written on that.
I'll do that myself, because I've read one of his articles, but he might have more recent ones with more details. So if you've got a particularly good one, if you could email me that would be great.
Mm-hmm. Alistair says, there are many Christians that believe in God who are renowned scientists, such as Dr. Francis Collins, but some tend to not want to be associated with or classified as creationists or intelligent design. Do you find that is common? And if so, what can you classify them as? Dr. Francis Collins, geneticist and physician, head of Human Genome Project, etc.
Right. And I think a very parallel situation is at the time of Galileo, because at the time of Galileo, Aristotelian philosophy dominated Christianity. So people would see the scientific framework through like the Ptolemaic cosmological system. So it's very hard for them to consider people like Galileo or Copernicus at times. It's not that simple, but that's a challenge. In the same way, many scientists like Francis Collins have grown up in a society that has embraced a materialistic view of the world. So it's something that they were surrounded by. So they've been shaped with that lens as strongly as the medieval Christians were shaped by the Aristotelian lens. So the challenge is for them to break out of that lens and see the world through a different framework. And the problem is, if you assume as a matter of faith that materialistic explanations have to be sufficient, then you have to reject intelligent design a priori. And the bottom line is we're all driven by the desire for acceptance. And if you want to be accepted in the academy, you have to deny design. Because materialism, and specifically neo-Darwinism, is like the creation mythology of our culture. So to be accepted, you've got to bow down to it. And what happens is that there's so much psychological pressure to do that, that fear of rejection can bias one's interpretation of the evidence very strongly. So what I find with many people that are critics of intelligent design is as soon as the arguments start to make sense, it's like a deep psychological trigger takes place where they simply shut down mentally. That's been my experience.
Yeah, I think that's the experience of many of us in the intelligent design community, unfortunately, when we speak with some of the evolutionary biologists at conferences and lay out some of the arguments for IDs, like they're just can't see it, even though it's staring them in the face.
Well, I mean, I think a really interesting movie was The Manchurian Candidate. And what happened was some American soldiers were captured by the Chinese, and they were conditioned to believe this certain soldier should be president. And like these trigger phrases would always go off whenever they would see this candidate. And what I find is people have been socially conditioned to reject design. And there's these trigger phrases that are almost like psychological hooks, like ID is not science. Evolution is supported by so many rounds of evidence. They're things that almost appear subconsciously as a defense mechanism against any argument against that perspective.
Do you want to maybe tell us about the positive arguments for intelligent design? Because we're often told, intelligent design is a God of the gaps argument. It's an argument from ignorance. How would you respond to that?
Well, and that's what's really interesting, because this is the irony of it, is that when you look at life, it doesn't even matter what design criteria you use. It looks designed. Everyone knows it. Everyone in the 1800s knew life looked designed. The whole point of evolution was to suppress what is obvious to us. So the idea is that evolution can explain away design because natural selection can mimic it. That's the idea. So that's the challenge, is that the positive evidence for design is pretty overwhelming. You could talk about information. You see information in the cell, and information is only a product of the mind. And I go back to my soup analogy. You can talk about things like intentionality. You see multiple systems working in unison for an intended goal that always points to design. You can talk about irreducible complexity. You've got systems that require a minimum number of pieces for them to function. You can talk about specified complexity. Like for the cell, what happens is matter can form in a fantastic number of ways. There's a large number of chemical reactions that can take place. And what happens is life requires a very, very small subset of those reactions and of those configurations. So you have to specify the complexity and capture it out of an enormous sea of non-functional, useless configurations. You've got the pattern of the fossil record and of life. I used to be part of an inventors guild, and I still actually consult for them. And what you find in innovation theory is that whenever you look at what's called a fitness landscape for, let's say, a machine, it's like a mountain. You've got a mountain with a peak, you've got a valley, and then another mountain, where the two mountains represent different design solutions to a problem, like a car versus a helicopter. On tops of those mountains, you have a very complex and rugged fitness terrain, which can even move with time. You have coevolution, things like that. But according to all innovation theories, if you're on one peak, you can optimize through gradual changes, like you can make your car better by making the wheels bigger or making it more aerodynamic, but it's impossible to innovate and go from one design logic to another design logic with contradictory constraints without making many changes at once. Because if you don't, you have to go downhill before you go uphill. So the pattern of nature looks exactly like that. What you see is new designs, like the Cambrian explosion, where these new designs with new design logics appear suddenly, and then once they appear, the basic logic stays intact. So again, if you look at innovation theories, you look at theories of information, specified complexity, you see enormous amounts of positive evidence for design, and there really is no response except to say by faith, all of that appearance of design was simply produced by evolution. But that's essentially just, it's like Harry Potter waving a magic wand. Natural selection can do this, natural selection can do that, versus recognizing that you see evidence of innovation, of intentionality, of coordination that points to a designer.
A question was submitted by Alistair. It says, when you hear theories such as Lawrence Krauss's universe from nothing, which is essentially saying with no intelligence or God, there was once nothing and something came from it, and from there, with no intelligence, the Big Bang happened, and so forth, beyond calculations on paper and theory, is that even remotely possible or scientifically plausible?
No, a lot of that is smoke and mirrors, because, like Lawrence, if you look at the various theories of the origin of the universe, you have things like cosmic inflation. So the idea is that in the early parts of our universe, you have this some part of space where you have some fluctuation which created a scalar field with a higher potential. That energy caused space to expand. That expanding space would spit out lots of bubble universes with lots of different laws. The problem is all of those theories have to start with some pre-existing laws and some pre-existing space. So they redefine nothing as actually something to make it work. All of those theories require a beginning because of what's called the Borde-Guth-Villankton theorem, and they all require fine-tuning. So you can't escape the evidence of a creator. It's almost like if you have a carpet and your carpet is too large for your room, there'll be a bulge in the carpet. And you want to get rid of the bulge, so you might hit it with a mallet. Well, that's the attempts that scientists make to get rid of the beginning or the appearance of fine-tuning is with some theory, like cyclic universes, like brains in multidimensional spaces. But those theories also have a beginning, and they also require fine-tuning, so it's inescapable.
When I posted about the webinar on Facebook, I got some antagonistic comments from Darwinists, Joe Fogey and the Unbelievable group, when I posted a link to the live stream. He said, "See, design protentism is a fraudulent pseudoscience designed to circumvent the American constitutional prohibition on religion in public schools." And I said, okay, you're right. Now let's go back to discussing the scientific arguments for it.
Well,
yeah, go ahead.
And again, it's a lot like the Wizard of Oz. It's like Dorothy wants to look at this mysterious man behind the curtain, and the wizard says, "I am the great wizard. Look at me. Look at my smoke. Look at my mirrors." And that's what you're seeing. The evidence for design is pretty darn obvious at many levels. You have to suppress it with these sorts of smoke and mirror type bombastic positioning, and you have to use technobabble to mislead people into what's staring them in the face.
Yeah, absolutely. And he replied and said, "Why? That would be like discussing the viruses on my computer with the nice man from Microsoft who keeps phoning me up and offering to fix them. What's the point of discussing fraudulent claims with a fraudster or someone who has been duped by one?" And I'm assuming that Joe hasn't taken the time to actually engage with any of your material, either in written form or on video. And so it's kind of a sort of standard tactic on the part of many Darwinians. They can't defend their turf, and so they just try to throw sand in your eyes and so hope something sticks, basically.
And my experience is people find the arguments most compelling if they're most knowledgeable about the science. I find the people that are most bombastic and critical are those that understand the issues the least.
Yeah. Ironically, especially among Christians, those that are theistic evolution are usually even worse prepared to defend evolution than the atheists are, which is very surprising. Aaron Ra, who's a well-known atheist in Texas. Do you know Aaron Ra?
I don't actually.
Okay, he's a quite well-known atheist YouTube personality, and he's often on the Atheist Experience along with Matt Dillahunty, and he's the one with long hair. But he commented on my public Facebook page, "Why did you invite me to a webinar with some apologists, the most dishonest occupation one can legally have? If you're going to talk about thermodynamics as it relates to the origins of life, you should talk to Jeremy England." And so he links to an article in Quantum magazine. I don't know, like, this isn't the way to further and progress a discussion on these issues, to just engage in this sort of ad hominem attack like this.
Well, again, the more clear and obvious the evidence, the more compelling the arguments, the more there has to be the attempts to misdirect people to other topics.
Yeah, I find that a lot. John Alaband asks, how would you respond to the claim that whilst numerous different constants, cosmological, gravitational, etc., appear fine-tuned, we do not know how the universe would look in every different scenario? In each case, if each case was wildly different, it may still produce a livable universe. I heard this claim in a debate between Craig and Krauss. I hope I've represented it properly. Curious how you would respond to it.
No, you represent it very nicely. It's the idea is that if the laws of physics were different, maybe we wouldn't get our universe, but maybe something very different with a very different type of life. That's the idea. The problem is when you look at the fine tuning, you need amazing fine tuning to get anything interesting. If you took a random set of laws of physics, what you would expect is either a lot of particles in a diffuse soup floating through space, that's it, or a bunch of black holes in the center, massive masses in the center, or particles floating through space. To get structures like organic chemistry requires things like the Schrodinger's equation that allows for chemical orbitals such that atoms can be close to each other. That's really, really hard. That creates the variety of the periodic table. So if you don't have enormous fine tuning, you would have nothing that could even resemble life. So you need enormous amounts of intentionality to get anything, and then to get particularly life, it has to be even greater. That's the response.
Jonathan Hanna says, what do we do about hard and weak scientism?
Well, again, I think it's helpful to point out to people that they will always see the world through a grid and hidden assumptions. So what you have to do is invite people to look at the world through another grid with another set of assumptions and ask, does that not make the world make more sense? So for instance, if you've got a pair of glasses that are the wrong prescription, everything is blurry. But there's no way someone can convince you of that unless you take off those glasses and put on a better set of glasses with a better prescription. So it's that inviting people to try to see the world through your lens that can be helpful to help them break out of that system.
Cool. Alistair says, do you think young Earth creationists that stick to a 6,000-year-old age are an embarrassment to scientists that believe in God and are Christian, or you can respect their views? With old Earth creationists such as Hugh Ross, who fully accepts a scientific timeline of billions of years, are they more credible?
That's a great question. I think what's happened historically is young Earth creationists have not always used the best science. And I think if you look at really, really good young Earth creationists, people that are young Earth and they really have studied the material, they would fully acknowledge that historically young Earth folks haven't always done the best job. So I think some of the science used in the past was legitimately embarrassing, but the better ones now are making much better cases. The really good ones also recognize that it's a really challenging road they're on. They recognize that a young Earth model for the moment seems to fit better, and that the young Earth folks have a lot of work to do. So I respect that. I respect young Earth creationists who recognize the state of the science. However, they feel that theologically that there is a need for young Earth because it resolves a lot of problems, things like natural evil before the fall. Like an old Earth creationist has to deal with things like cancer in animals before the fall. Whales eating, or killer whales eating dolphins or eating seals, things like that. So the young Earth position I can respect. I just would encourage young Earth creationists to be sure that they understand the science very clear and they know the challenges. So that's my only perspective. Now, also what I found is evolutionists have presented arguments which are no less problematic than those of the early young Earth creationists. So I think everyone needs to be careful about their science. That's my encouragement.
Right. And I think it often comes down to epistemology, because epistemology, for those that aren't conversant with philosophy, is basically the theory of knowledge, how we come to know things to be true. And generally, when we're trying to come up with a conclusion about reality, we find that there's evidence pointing different directions, right? Mm-hmm. Because we're not omniscient. We don't have all the information, all the facts. And so we find evidence that seems to point in different directions. And so it then becomes a balancing act of, okay, which lines of evidence are we going to prioritize and give more weight to? Now, now I'm not a young Earth creationist, but I think if I were a young Earth creationist, the way that I would go about it would be to argue that if I was convinced, which I happen not to be, that the text of Genesis committed one to a young Earth interpretation, then I think I would probably argue, okay, we have such good reason to think that the scripture is indeed the word of God, based upon various lines of evidence, that it must be factored into our epistemology. And so if that points in the direction of an old earth, of a young earth, then that should be given weight, just as the scientific evidence should be given weight. And then the question of, okay, which gets the most weight is then actually a more tricky and complex discussion than it might appear on a first glance.
Right, that's a fantastic point, because when you deal with every worldview, every framework has tensions, and you have to manage tensions.
Mm-hmm.
So if you are, let's say, within a young earth framework, then the perspective is that the tensions of not accepting a literal Genesis are greater than the particular tensions between a young earth scientific model and pieces that don't quite fit. While others might argue that the tension of, let's say, going with a less literal view of Genesis is less than the tension of the science. So you're right, it's really a matter of managing tensions, and it's actually a continuum. Every Christian has to kind of navigate those issues in different ways. Mm-hmm. Should women wear head coverings in church? How do we bring in issues of like cultural context? How do we understand tensions in the Gospels? Is that the literary genre? Is that the freedom the authors had? Or is it better to argue that there's ways they can be perfectly reconciled word for word? So yes, these are all tensions we have to navigate.
Yeah, and I've often, I counsel a lot of people who are struggling with intellectual doubt, and one thing I often say is, there's no shame for a Christian to have unanswered questions that he wrestles with, because it's not rational to go from one worldview that has unanswered questions to another worldview that opens up a whole range of new unanswered questions, because then every worldview ultimately is going to have tensions, and every worldview ultimately is going to have unanswered questions, because we're not omniscient. We don't have all the facts. And until we have all the facts, there's always going to be issues that we haven't resolved within our worldview. And I find that people often become so fixated on the objections to the gospel or the objections to faith that they miss sight of this tsunami of evidence for the gospel being true, because there are far stronger and far more numerous objections to non-belief than there are to belief, I would argue.
Yeah, that's a fantastic point. A way I love to talk about it is it's like a lens. The center of the lens is what's clear, and the periphery can be more unclear. And with Christianity, the center of our lens, the resurrection, creation, our desire for purpose, point to the idea that our faith is true, that our lens is good, while the periphery questions are more complex. In other worldviews, the center issues are contradictory and unclear. So I would argue that the center issues fit with Christianity much, much better.
Mm-hmm. An anonymous viewer asks, how effective have you found apologetics from science in evangelism? Are there certain places in the world or particular people groups to whom they are more compelling? If so, why do you think this is?
Oh, that's a fantastic question. I think, well, there's different aspects of apologetics. I find that a lot of Christians who may have lost their faith because they think science and faith are in conflict, these discussions are exceptionally helpful. I just did a talk a few months ago, and a woman who came had read Richard Dawkins' The God Delusion, and she believed that faith and science were in conflict, so she left the faith. After the talk, she came back to the faith. I've seen that a lot, actually. Another place I find is places where people are basically raised secular. They've just always been told that science and faith are in conflict. They don't have deep emotional barriers to the faith. It's just what they've always just accepted, there was no God. I find the science discussions are extremely helpful in that context. It helps essentially to pull people out of the matrix. Where they're less helpful is when people have more emotional barriers. They've been hurt by the church. There's other motivations they have to reject it. And then it's more helpful to look at what those issues are before you deal with the science.
Kevin Ross, who himself is a physicist, says, please comment on this response to the compensation argument. He says, and he has a list of bullet points. He says, the second law of thermodynamics allows for local decreases in entropy as long as the entropy increase in the surroundings compensates for the loss in a local environment? My answer, this compensation argument only addresses what is possible. And he says, what about probability? What about explanation? We know that the energy flux, example from the sun, does not increase order apart from the operation of a special entropy-reducing mechanism. The simultaneous influx of energy and reduction of entropy requires an explanation. Without a plausible physical mechanism, probability is very much against you, and as a materialist have no right to suppose this is true. Challenge to the naturalist, provide me with just one plausible mechanism by which local spontaneous decreases in entropy produce sufficiently compensating increases of entropy in the surroundings during the formation of life.
Yes, that's a really nice summary of what I had talked about, that you do have examples where local entropy can decrease, but that's only that are exothermal, because the energy released is actually creating entropy in the surrounding environment. The problem with life is you have both an increase of order or decrease of entropy and an increase of energy. There is nothing in the universe that does that. And as the person mentioned, you have to have a mechanism that will take the energy entering your system and somehow process and couple it to the ordering you're trying to create. Raw energy actually increases entropy and takes you in the wrong direction. So that was just kind of a nice rephrasing of what I talked about.
Jonathan Hanna asks, do professionals within your field adhere to verificationism? If not, do you know of any professionals who are non-believers who have denounced verificationism?
Well, in all honesty, I find most scientists don't think about those issues so much. I mean, they're not thinking about whether they're positivists or vericationists or critical realists. They just do science. In fact, a lot of scientists almost get flustered if you talk about philosophy. So there's not nearly as much self-reflection as there needs to be in the scientific disciplines.
Yeah, I absolutely find that in my conversations with scientists, is that they have absolutely no training in philosophy of science, which is a real shame, because philosophy of science really molds your thinking and helps you to work out how to form conclusions and reason well and things like that.
Yeah.
And also helps you with demarcation. And perhaps if people had studied more demarcation philosophy, how to separate science from non-science, then there'd be less claims that intelligent design is not science, because the arguments against it, as far as demarcation are concerned, are very, very shallow and poor.
And I think what happens, a lot of scientists are actually hostile to the whole idea of philosophy of science, because they want to put themselves on this pedestal that they're the pinnacles of reason and knowledge. So to have people shake their pedestal makes them nervous.
Yeah. So Alistair says, do you think many scientists are bitter or angry against God that can be a major reason why they try to rule out any possibility for intelligent design? Example, some have had bad experiences with Christianity, etc., or with someone like Stephen Hawking. Some even say because of his condition, he is bitter against God.
I would say that's definitely partially true, but I think also what happens is it's like a culture. Like going into the scientific enterprise is no different than, let's say, entering the Mormon church or any other religious system. You're inundated with a certain view of reality, and you just sort of instinctively put on that set of glasses. So when you see the world through that lens, faith becomes less plausible, and all of the people around you reaffirm that view of reality. So I think that's part of the problem. So there just needs to be more Christians that present an alternative perspective. And also people in those environments need support. Like it's as hard to pull a person out of a materialistic position who's a scientist as it would be pulling a person out of the cult, because their community, their social environment is pressuring them to accept a certain position. So for them to leave that position is tremendously costly. So they need as much emotional and community support as a person leaving a cult.
Yeah. Someone on Facebook submitted a question. They wanted to ask about an article that was published in Quantum Magazine. It happens to be the same one that Rna was linking to. He says, I'll read some portions from it. He says, it's just a more detailed version of the argument that just as a crystal is an inevitable result of certain environmental factors given the correct initial material, so is life. So basically the article published in Quantum Magazine, it's about Jeremy England, a 31-year-old physicist at MIT, who thinks he has found the underlying physics driving the origin and evolution of life.
Right.
Are you familiar with this work at all?
Yes, I think I
Okay.
saw an article about that. And again, it's really just a restatement of self-organization theory.
Mhm.
It's the idea, because you've got these non-equilibrium systems that create patterns like tornadoes, patterns like a Rayleigh-Bernard convection. Maybe life is simply one of those patterns. But all of the scientific evidence speaks against that idea. The more we know about the science, the more it looks like life goes against what nature wants to do. So for instance, if you have an experiment where you put a lot of organic chemicals and you start to shock it, or you put in UV light, what nature wants to do is create smaller organic chemicals and tars. It doesn't want to create long chains which can bear information. So all of these claims are based on faith. They're not based on actual reality of what happens in a laboratory.
Mm-hmm. Yeah, I also find that usually when people discuss these scientific breakthroughs in the origins of life, the one thing that's conspicuously lacking in terms of having an explanation is the origins of the information content. And that is precisely the thing which is uniformly and habitually associated with intelligence or conscious activity, right?
Yes, yes. It's both. They can't explain the information, and they can't explain how chemicals would do things that are the opposite of what they would normally do in everyday reality.
Right. I mean, the origins of life is no trivial problem. Besides the information enigma, you also have to explain the homochirality of the amino acids. You have to explain the origins of the plasma membrane to keep the cell together. You need to explain a whole range of different things. The origins of the information in the first RNA polymers, the origins of the ribonucleotides themselves, and so on. So there's a whole range of different things that need to be explained. You need, a protein synthesis apparatus like the ribosome or something. So it's no small problem.
You're really seeing what I would call a materialism of the gaps arguments,
Mm-hmm.
that whatever they think they've solved, they only think they solved it because they haven't understood the underlying physics enough.
Yeah.
Whenever, in every area, whether it's membranes, whether it's a genetic code, whether it's formation of polypeptide chains, the more you understand the chemistry and the physics, the more it looks like nature does the opposite of what you want.
Mm-hmm.
So the homochirality, all that are examples, but the overarching problem is that virtually everything goes in the wrong direction.
Yeah. Marcus Eberlin on Facebook says, "Well done, Brian. What a pleasure to listen to someone with scientific but also deep philosophical and theological knowledge. And he wants to know what came first, proteins or RNA?"
Oh, in terms of what the origin of life people think, or can I take?
Or your take, I guess.
Well, again, I think the whole system had to come together at once, because you're dealing with the complexity threshold where you have to have the proteins, because that's what's going to have enzymes that can couple the reactions in the right way. You've got to have the DNA to store the information, because your proteins break down pretty quickly. You have to have it all inside of a cell membrane, or it would just diffuse in the ocean or in a small pond. So if I were to take a time machine back in time, what would we see? I think we would see some extraordinary event where all the chemicals just kind of came together in one fell swoop to do something truly extraordinary.
Mm-hmm. Just for those here who don't have the background, do you want to maybe just tell people what the RNA World Hypothesis is, and maybe highlight some of the problems? Yeah.
Sure. Yeah. What happens is the big question in the origin of life is what came first. Some people think proteins came first. So amino acids were formed. They formed into proteins. The proteins turned into enzymes and structures. And there's lots of problems with that, like the sequencing problem, the problem of how do proteins then turn into, translate the information into DNA. So there's lots of problems with that. The RNA World Hypothesis is the idea that RNA came first. And the reason they like it is because RNA can both hold information, and RNA in principle can fold into what are called ribozymes. And that's like an enzyme with a protein, but it's an enzyme produced by an RNA molecule that can then do various features. So because RNA can carry on both the functional role and the information role, they think that, yes, thank you. Sharice is telling me that they're ribozymes, not enzymes. So RNA forms ribozymes. So what happens is they think the RNA can do lots of useful stuff. So they think that's helpful. The problem with the RNA world is, one, it's exceptionally difficult to get nucleotides. Two, it's hard to get them to link up properly. Three, the RNA, the nucleotide sequences don't do a whole lot. Their activity is very, very limited. And then three, it's hard to go from that to a protein world. Like, how exactly is that supposed to then translate into proteins? So the RNA world is most popular simply because it has fewer problems than everything else, but it still has enormous numbers of problems.
Yeah. For one thing, the RNA has the extra 2' hydroxyl group, and so that makes it less catalytically stable, of course. So it's less stable than DNA. It's also single-stranded, which also makes it far less stable. And also, there's been the evidence from the ribozyme engineering experiments, which, by the way, for those that are listening, Stephen Meyer discusses extensively in a whole chapter in his book "Chicken in the Cell," DNA and the evidence for intelligent design. But basically, the ribosome engineering experiments have not showed that RNA is an efficient replicator in terms of replicating its full length. Anything to add to that, Brian?
I know that's excellent, and I did an article that'll come out, I think, next week, that talks about this challenge of how do you actually get from, let's say, these ribozymes really existed, how do you then get to proteins? And there's a professor named Yaros who's come up with the idea of direct templating of stereochemical affinities, and his argument is that you can have these nucleotide sequences, and they can be more strongly attracted to certain amino acids. And the idea is that the amino acids they're strongly attracted to are because those sequences contain more of the codons or anticodons associated with that particular amino acid. So what he's trying to do is argue for a natural templating process. The problem is it can't work, because if you imagine a sequence, the idea is that you've got this very long sequence of nucleotides, which has disproportionately more codons in the binding sites to cause it to wrap around a protein or an amino acid. But the problem is, to get amino acids to link together, you've got to have this enormously long RNA strand, which wraps around lots of different amino acids. But if the RNA is wrapped around it, what on earth is going to allow the amino acids to link into chains? And even if that worked, then how do you get from that to the RNA and DNA we have today, where it's a simple sequence of codons? Not to mention, where did the sequence information come from to begin with? Because if you've got a ribozyme, the sequencing of a ribozyme is completely different from the sequencing of amino acids that form into useful enzymes. So it doesn't help to go from RNA to proteins, because you have no information for the proteins. You've got to start with the proteins with the right information and then translate that into the RNA. So Yaros' whole model goes in the wrong direction. So these are some of the problems.
Mm-hmm. Do you want to maybe comment on the fine-tuning or optimization of the genetic code? I don't know how much you've read on that.
I've read a little bit. You're welcome to chime in, but the basic idea is that the particular code we have, which means the way that amino acids associate with the triplets of nucleotides, is extremely efficient, so that you have, like, let's say, an error in one of the nucleotides won't cause as much change that's harmful as other types of sequences. So it's very optimized for error protection. It's optimized perhaps for encoding multiple sequences of information at the same code. So there's lots of optimization taking place, but please be sure to say more.
Yeah, sure, and that's absolutely right. There seems to be multiple levels of fine-tuning and optimization of the genetic code, which is really fascinating, because from a materialist viewpoint, where you're explaining all of this in terms of chance and necessity, how do you explain the origins of such an optimized genetic code? Because remember that if you change the codon to amino acid mapping, codons are triplets of nucleotides, or ribonucleotides in the RNA, and each of these codons of 3 nucleotides codes for a single amino acid. There's 20 different amino acids that are used in life, and there's 64 different codons. And so there's this redundancy where often an amino acid could be coded for by multiple codons. And there's a whole, there's a huge space of ways that you could arrange that mapping of codon to amino acid mapping. And I wouldn't say that the genetic code we have is absolutely the best possible. I don't think anyone has argued that. I don't think we need to argue that, just as we don't necessarily need to argue that our universe is the best fine-tuned universe that you could possibly envision. But nonetheless, it is sufficiently finely tuned and sufficiently optimized that it's very, very difficult, in my opinion, to explain it in view of chance and necessity. Because remember, if you change or alter the codon to amino acid mapping, you are altering all of the polypeptides made by the cell, right? And that is going to wreak havoc if you're just searching through the sequence space, or rather this mapping space, if you will, however you want to talk about it. It seems to me to be very, very problematic for a non-design viewpoint.
Yeah, and what's happening is there's research that continuously shows how brilliant the code is. So for instance, people used to think that you have redundancies in your genetic code which were not relevant. So in other words, you might have multiple codons that code for the same amino acid. But what they're finding is that they do matter. So you might choose one codon versus another, and that affects the speed at which the polypeptide chain is created at the ribosome. And that difference in speed actually affects the folding. So differences that we thought weren't important are actually essential to this process.
Mm-hmm. Alistair says, the famous debate with Bill Nye and Ken Ham in 2014, which attracted a lot of publicity. Did you watch it, and would you say both made good points, or was it pretty one-sided? Who came across better? Have you been to Ken Ham's Creation Museum or Art Encounter?
Yeah. Yeah, I saw the debate, and I don't think it went as well for the side of Ken Ham as he particularly would have liked. He focused on certain. The problem was there's a lot of evidence he could have brought to the table, which would have been helpful to bring up. So it didn't necessarily go as well as it would have been. He may have desired, but I think his desire was more to inspire the home base more than to convince skeptics. So it probably did as well as what he wanted to do.
Yeah.
I haven't been to the museum, by the way.
Yeah, I watched the debate, and I was quite disappointed with Ken Ham's performance because he made a lot of assertions, but didn't support them with argumentation. Yeah. And I thought that the debate was a bit of a mismatch, because it would be nicer to see Bill Nye go up against someone like Andrew Snelling, or someone, Andrew Snelling's a PhD in geoscience, or geology, so he's much more clued up on those things than, say, Ken Ham, who doesn't have those scientific qualifications, or even a biologist who adopts the Earth position, like Paul Nelson, perhaps, or someone like that. But I thought it was a bit of a mismatch. And also, Bill Nye made a lot of mistakes in his arguments that Ken Ham didn't pick up on as well. Particularly, I don't actually remember all of them because it was years ago since I watched the debate, but I remember he made some big errors on biblical material as well. Jonathan Hanna says, have you all published peer-reviewed research in reputable journals?
I have.
Yeah. And in case this is being inspired from common claims by Darwinists that ID proponents don't publish in peer-reviewed journals, there's a whole article, and there's a webpage at the Discovery Institute website which lists many, many articles that have been published in peer-reviewed scientific venues which promote or argue for intelligent design and its related concepts. There's also a technical journal that is published by the Biologic Institute called Biocomplexity, which is an intelligent design friendly journal where it facilitates discussion of intelligent design related ideas, and there have been a lot of papers published there in recent years. Our biochemistry friend Therese Nartney from Texas has her hand raised. Therese, go ahead.
Can you hear me?
We can.
My last name is not Nartney.
Narty, yes, I know.
Platchny.
Sorry, Therese.
It's okay.
Oh, this looks like a really hostile audience member. I'm kind of scared.
Good, you should be. No, Brian, oh my gosh, that was amazing. I'm really proud of you.
Thank you, Therese.
So something I picked up on what you said a few minutes ago about the people who are less versed in the physics are the ones who most often make the mistake of thinking that, you know, these are not really problems for life. And I have this really dire prediction, and I want your opinion on whether this is like Chicken Little, the sky is falling, or whether this is like sound, because I'm very interested in the psychological components of how we reason and the impact of our emotional like filters. We're not artificial intelligence that's just been given raw program and we run it, and the only problems we have is if we overheat or something. Like, no, we we actually have a lot of conflict of interest going on inside of ourselves, you know, as we are trying to reason. And I noticed that I think with people in pedagogy are finding it harder and harder to get students to synthesize information. And that basically means to take it from just a concept that you learned to something that you can apply yourself, and you know the nuts and bolts and how it's put together, rather than you've just memorized it for the test and you regurgitate it and move on with life. So students complain that they don't get the exact same question on the test as they got in their practice test, because they think that's unfair, that they would have to actually expand their mind and utilize the information. And I feel like this is connected to let me just try and formulate my prediction here, which is that when you have cognitive dissonance, it sucks. It's like one of the most painful things, okay? And the ways that we can deal with that dissonance is to dissociate from the pain, dissociate from from one belief or the other. So it's when you hold two beliefs as true that are in conflict with one another, okay? And so that's what produces cognitive dissonance. Two or more, I guess. And so if you have this intuition that life is designed, right, that's something that is a part of your core, like, almost want to say hardware. It's not even just like hard software. And then you're being fed information on the technical level, like say you're in a physics class and you're learning about thermodynamics, and then you're like, okay, all of this is kind of in conflict with what I'm learning in biology, which is that, you know, life came spontaneously from non-life. So that's dissonance. So something has to resolve in order to not live in constant pain. And so what I find what people do is they just take the origins of life question off the table if they're molecular biologists or biologists or whatever. And that just gets to go over into that realm of, you know, what does that mean? That's philosophy. We can't know, I'm sure. Or they'll say it's basically solved. Like they've solved that problem. And then you ask them to tell what the answer is. And then it's like they don't really have a very, you know, good answer or satisfactory answer to me, but it seems to be satisfactory to them because it's just a very hand-wavy narrative that doesn't challenge Darwinism. And so then, but what I think is for people who are going to start thinking more and more seriously about this question, I almost think that there's another way to resolve the dissonance, which is to sort of like throw out the laws of physics as we understand them. And when I say throw out, I mean like warp them, kind of. So you have these things like Maxwell's demon, and you could probably explain them better than I could. But there are these exceptions and probabilistic like impossibilities that the law or the equations say are basically there's a finite probability of something like this ever happening. Like all the gas in this room should be equally distributed, but at some point it could all end up in the corner. Why not? You know, I mean, then that just doesn't follow our experience, but somehow you have to be able to explain things like that happening. So why don't you give a better explanation for these types of, so I guess what I'm saying is the statistics would have to be overturned and become, I don't know. I guess what I'm predicting is that people's minds are not going to be able to hold the reality of like what actually happens in real life, because there have to be so many exceptions to what actually happens in order to allow life, that they're going to instantiate that into the laws of physics and make that the new physics. And then everything is going to fall apart.
That's really a very insightful comment. There's an idea called sticky theory. And what sticky theory is that if you have some deep-seated belief that's emotionally embedded in your psyche, and you hear evidence that contradicts what that belief is, you will actually believe what you believe stronger, not weaker. Your brain literally warps the information coming into your mind, so that, for instance, if let's imagine there was a Darwinist who listened to what I just said this last hour and a half, and you asked him to repeat what I said, what that person would think I said is not what I actually said. You see this all the time on reviews, critical reviews of like Stephen Meyer's books, Attacks Against ID. They literally, I don't think they're always being dishonest. I think their brain is literally scrambling the arguments and reshaping them into something they can handle.
Yeah.
What happens also is, and this is where these trigger phrases take place, because what happens is when your deep belief is confronted with evidence that contradicts it, your cognitive centers shut down and your emotional centers kick in. So they respond often with lots of all caps letters, or they respond with snarly comments or references to journal articles that might have nothing to do with what you're talking about. Also, the criteria they use to embrace evidence gets raised for your side and lowered for their side. So any argument that supports their side and contradicts what you say, they'll latch onto regardless of how weak it is or how tangential. It's interesting to note, when Douglas Axe did his research on the rarity of proteins, his research was peer-reviewed by top scientists. It was consistent with previous researchers. The critics all appealed to a blog post, I believe it was on Panda's Thumb, by a person who wasn't even a protein chemist. So what was clearly an inferior model of information was embraced over peer-reviewed journals because of the lopsidedness of how evidence was evaluated.
Right. So do you think that there's a way to scientifically measure what you're talking about? Like, and when I say science, I mean not like psychological science and interviewing people, because that's valid, but I'm looking for like fMRI and to actually witness the process of what you just said, like on that level.
Oh, absolutely. Yeah, I don't know if anyone's ever did that, like watching a Bill Nye debate, but I think this is pretty well established of these different centers of the brains lighting up.
Wouldn't that be like, I mean, do you think that that would be helpful to present someone with what's happening in their own brain while they're being presented information that conflicts with their worldview?
Well, part of what I've done before is I've done that. I say I'm kind of like Morpheus trying to pull you out of the matrix. And what's happened to you is you've been psychologically conditioned to respond emotionally to these arguments. So you have to be aware that you've been trapped in a false reality that distorts reality. So you've got to make an effort to overcome that and to really listen to what I'm saying. The challenge is people won't do that if it costs them. So a scientist that could lose their job isn't going to have a lot of motivation to spend the emotional energy to overcome these biases.
Well, see, I just recently watched The Matrix, and I think it's a beautiful analogy. And the thing is, like, he gave Neo a choice of the red or the blue pill. And I think that speaks to like the type of people that we can maybe make more progress with, or people who have already, you've been thinking about this yourself, you know, something's missing, don't you, Neo? You know, like before he even got out, you know, there's just people who are thinking more deeply about this and people who are like, nope. And yeah, it costs a lot, but it's about freedom. And so I don't know, like, that's, I guess what you're saying is we have to be there to support people.
Exactly. It's no different. Pulling a person out of being a materialistic scientist is no different from pulling a person out of the Branch Davidian cult. It's the same social dynamics. So people that are breaking away from that lens need emotional support to do so. And that's why often top scientists are more open to ID arguments, because they have nothing to lose. They've already established their reputation, they've got all they want, they may be close to retirement. So they're the ones that are going to be much more able, they'll have the emotional space to actually listen to the arguments and absorb them.
Well, I don't have any more to say, but thank you so much for entertaining my dire prediction.
And you're right, because again, when I read the articles trying to explain how to overcome these gaps, they appeal to more and more fantastically implausible scenarios. So I call it the materialism of the gaps. As the science advances, the denial design becomes more difficult, the more their materialistic stories collapse. So the more they have to escape into realms that are not well understood or into increasingly implausible arguments. And you're seeing that pattern taking place.
Yeah.
All right. Well, thank you, Therese. Yeah, I completely agree with what you were saying, Brian. It's difficult to make someone understand an argument when their entire career depends on them not understanding the argument.
Exactly.
Alistair says, do you think life outside Earth is possible, or God only intended for it to be on Earth? Most scientists say they think it is highly probable, but that appears not to be based on real evidence, more conjecture. There must be, probability says.
Yeah, I think people like Guillermo Gonzalez in his book, The Privileged Planet, talks about how difficult it is for a planet to support life, particularly at the level of technological advancement of ours, particularly that allows species to exist from the equator to the poles. So, there's a debate of like, how unlikely is it? Like people like Hugh Ross will give exact numbers that are very, very, very unlikely. So it's essentially impossible. People like Guillermo Gonzalez are super, super conservative. So they don't want to use a number unless it's been, accepted by virtually everyone. My gut feeling is that we're at the point where there's no way that any planet in the visible universe could support life like ours by chance. So if it did, it would be designed to do so. And whether that's the case or not, I don't know. That gets into more theological issues. My suspicion is no, but I can't be certain.
Jonathan Hanna says, if someone has tenure, can't they be more open to the evidence? I'm not sure that is like a cult.
Absolutely not. There is a professor, professors that have tenure can still be punished. We know professors that once they don't even necessarily support design, they're just willing to talk about it. They can lose lab space, they can lose funding, they can know that other associates won't work with them. So having tenure does not protect a person from going against the system. It helps. I mean, it certainly helps, but it's not complete protection.
Great. Well, there's no more questions currently. Does anyone want to submit a last minute question? If you want to submit one, then now would be the time to do so. If you want to raise your hand, you can also do that. If not, we will wrap up. Going once. Going twice. Okay. Let's wrap up at that point. Thank you so much for coming on and for sharing your time with us, and your knowledge of these areas has been very insightful.
Thank you. It's been a pleasure.
Yep, we must have you on again at some point in the future as well. All right. Well, have a great rest of your day.